Saurav. It's been almost 13 to 14 years I'm a part of IT industry. I came from business intelligence, data warehousing background, and my major area of specialization is data analytics, digital technologies like cloud-based technologies and all. Solvexis, if I could brief you about Solvexis, is a group of IT professionals. We are not from any local consultancies. So we, as a group of IT professionals who came from different technologies background, we joined together and we guys conduct online trainings based on our project experience, based on our practical experience. There are basically three areas which we focus. The first is the training. There are a lot of technologies like data science, machine learning, data analytics, DevOps, blockchain, big data analytics, cloud-based technologies like AWS, Microsoft Azure and all. Based on our project experience, we guys conduct these online trainings. Now, the way we conduct these online trainings is quite different. The first of all, we follow the content in terms of the topics or the or I could say the activities which we perform within our organization, within our project. So we actually take the references from those topics and those assignments, and we design the training accordingly, and that's how we conduct these online trainings. These are the live interactive practical trainings. The way we are conducted, we join right now in a same way we conduct each and every classes. Now at the same time, we put the minimum number of students in one particular batch. We are not running the training batches like 10, 15 or 20 students in one single batch. Most of the time we prefer to put a almost like 6, 7 students in one batch, so that we will have a good healthy discussion with each and every participant. The second thing is the internship one. This is the new area actually which we introduce, because most of the time as a trainer we feel like, during the training program, to teach somebody we have to take some basic example so that the person will understand the concept. Now this happens for each and every learning area. Wherever you are going to learn something, you have to learn from the basics actually. From you need to take some basic examples. But once we learn any particular concept or any particular technology, we need a space where we are going to implement our learning, implement our knowledge. That is the internship month. Once your training gets completed, we are going to put you in 1 month free internship, in which we are going to give you some 3 or 4 real-time projects from our side. And whatever you learn within the training program, you are going to put that knowledge and implement a solution. So that is the actual benefit of this particular internship, that the participants will get the exposure while working on the real-time project. These are the remote internships which we actually conducted. The third one is crowdsourcing. Crowdsourcing is a little bit, you could understand. There are organizations based out in India, US, and UK, small scale and the medium scale organizations who have some task, but they are not looking for a full-time resources. If I talk about the data science or the data scientist, they are looking for some sort of support from the data scientists or professionals having good knowledge in data science, statistics, and machine learning, but they are not ready to hire them. So they always look forward for a trained professionals who can support them for a short period of time. In crowdsourcing, as of now, whatever the database we are creating for so far for our students, who join our training programs and all, we keep on sharing those particular profiles and the students information with those organizations. Because now it's been 4 years we guys are conducting these online trainings in a market. I mean, now the audience is going to recognize us. They are going to know like who we are and all, and the same way they are also going to refer our group within their organizations. So at the same, in a part of the crowdsourcing, they are the organizations who always come back to us and say, do you have any trained professionals on data science or on AWS and all? And they are going to assign them some task, and at the same time they are going to pay them as well, right? So from our side, we also look forward to share your profiles, your experience with those organizations, so that after the training program, if by any chance you didn't get a opportunity to work full time on that particular technology, but still you have some work which you can perform as a freelancer, right? Because continuously we have to implement our knowledge, our learnings, then only it is going to work. So in other words, if you could see, the whatever is the amount for the training you are going to put as a fees, from the third month we look forward to return you back. So these are the three major areas which we cover, which we on the basis of which we are going to conduct our training program. The first is the live interactive training. Veena ma'am is going to take your session today on that. The second is internship, and the third thing is crowdsourcing, right? So now Veena ma'am, over to you, and let me make you a presenter. Veena ma'am, you're a presenter now, so you can share your screen. You can continue.
Yeah, thank you so much, Saurav. Hello, everyone. Welcome to Solvexis. So I'll be your instructor for Mastering Data Science course. So I'll just brief you about myself. I am a data scientist. I work in an MNC as a senior data scientist, and I have around 12, 13 years of experience in this field. And over a period of this time, I have worked on a lot of interesting projects. A few of them are attrition predictions, recommendation engines, and I've worked on a lot of predictive analytics problems. And I've also conducted many classroom sessions and a few online trainings before this. So let's begin with today's session, today's demo session. So I'll be talking about what data science is, what a data scientist does, and then I'll be slowly moving on to machine learning. I'll be briefing you about the basics of machine learning, and then I'll take you through a, just a minute, I'll just, yeah, Yeah, and then I'll take you through a real example, an implementation using R. So let's begin. So what is data science? So data science, it is a process. It is a process which involves various fields like data analysis, machine learning, visualization, and etc. So the very first step is defining the goal. So whenever there is a business problem, a data scientist has to come up with a proper business goal. For example, the business comes up with a problem like the sales are going down. So as a data scientist, you need to come up with a quantifiable goal. You need to say that I'm going to work on the data and I'm going to reduce the uh, I'm going to increase the sales by 10, say 10%, increase the revenue by 10%. So you need to come up with such quantifiable goals. That is the very first step of this data science process. After that, once the goal has been defined, you need to understand what information you need, what kind of data you need. And once you have a clarity on that, you go ahead with collecting the data from various sources. And once you have the data, you will have to pre-process the data. Now, in as many of you work with data, you all might know that data never comes in a very clean format. So you have to do a lot of processing to bring it into the format that you can actually work on. So that happens in this second phase, collection and managing data phase. So once you have the goal in place, once you have the data in place, the next step is building the model. Say you want to predict some things. Say you want to predict when will a customer leave your you suppose you are a product based company, you have a subscription model, you have many customers who have subscribed to your product, and your business your goal is to identify, to predict when will a customer uh, leave the subscription. So for that, you need to pick the algorithm, which you need to identify the correct algorithm which will help you in solving the problem. Once you've identified that, you need to build the model. So this is where the machine learning comes into picture. And then once you have built the model, you move on to checking the quality of the model. You need to see if this model is actually helping you out or not, if this model that you have built is actually good or not. And once you are done with that, you need to present your model to the stakeholders. So you need to do some reporting, visualizations, etc., to present it to the stakeholders. And once everyone is convinced, you need to deploy the model. So a person who is involved in all these phases of a project is a data scientist. So a data scientist is not someone who just deals with machine learning. Machine learning is just one phase of data science. So along with along with machine learning, the data scientist has to work on all these aspects as well. So this is small introduction about data science. So I just wanted to say that data science is not just machine learning, it's machine learning along with data analysis, visualization, etc. So that is about data science. Now let's understand what machine learning is. So before getting into the details, let's take a small example. Let's try to understand how a computer, how will you make computer do a task. Suppose you want your oven to be turned off after some time. So if you want to instruct a human being, you'll just tell him that okay, you turn off the oven when the timer goes off. But you can't do the same with a computer. You have to write a code. So you write this two lines of code saying if oven timer alarm goes on, then a button status should be pressed. So by doing this, the computer, you will be able to instruct the computer to turn off the oven. So this is the traditional way of programming. You write codes for whatever task you want. Yeah, so that is how you traditionally, that is how you instruct a computer to do some task. Just like how you would do it with a human being, except that the language here is different. Now, let's take a slightly more complex example. Suppose you want to teach a kid how to identify animals. So here, how would you tackle this problem? We cannot go about telling the kid that okay, if the animal is huge and black, it is an elephant, or if it is very an animal with a very long neck, it is a giraffe. We can't give rules like that because that would take forever to finish. So instead, what we do here is we tell the kids, we show pictures of animals to the kids, and then they just learn it on their own, right? So that is subconscious learning. But we can't expect such a subconscious learning to happen automatically with computers. So with computers, if you want to follow the traditional programming approach, you will have to give rules for each of the animals, which, as mentioned some time ago, which will fail, right? So instead, what we want the computer to do is we want the computer to learn by itself. We uh, we want to make the computer learn on its own without being programmed, and that is machine learning. So here in this slide, you can see the difference between the traditional programming and machine learning approach. So in traditional programming, what happens is you write a program and you feed into your computer, and the computer will give you an output. Suppose you want to draw a line. Now you write a small code for this, and along with the code, you give your x coordinates, y coordinates, and your slope, and the computer will be able to draw a line for you. But if you want your computer to identify the color of a line on an image, then traditional programming approach is not how you approach this problem. So here instead, what you do is instead of giving a program to the computer, instead of giving lines of codes to your computer, what you do is you give output to the computer. Now, when I say giving output to the computer, what it means is you tell your computer, you give it a lot of examples, and you tell your computer, this is how I want you to, this is what I want you to do. This is the task that I want you to do. So you now the computer has to learn by itself. Now the computer has to come up with various patterns in the data. It has to look at this input data, and it has to come out with patterns, learn the patterns, and then here it comes out with the output will be a program. Now this program is something which can be used a uh, on some unseen data to accomplish this task. So if you see in traditional programming, the input to the computer is a program, and the output is and you get the output. Whereas in machine learning, you give the output to the computer. You give a lot of information which looks like your output, and then you get a program as your output. So you can see there's a loop here. So this is the main difference between a traditional programming approach and machine learning approach. When we look at examples further in the class, this you'll get a better idea about what I'm talking now. So now let's move on to the types of machine learning. So basically there are three broad classifications of machine learning: the supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is where you know the output. Let me take an example. Suppose you have a lot of images of cats and dogs. and each of these images are labeled. Now you want your computer to identify, you given some random images to your computer, and you tell your computer, okay, identify which is a cat's image and which is a dog's image. So here the input that you're giving to your computer is labeled, meaning each of the images that you're providing to your computer has got the labels, which says if it is a cat's image or a dog's image. So here what happens is the computer learns, and the computer tests it on the data, and it compares with the actual output. So the computer learns and it predicts, right? It predicts and it comes up with some prediction which is tested with the actual data. Now the computer here has a way to check if it has predicted correctly or not. So in a way, the learning process is being supervised. So this is supervised learning. So let's get back to the cat and dog example. So what happens here is I give my computer a lot of images of cats and dogs, and each of these images are labeled. So the computer comes up with the model. Now I use this model on some data which does not have a label, which are unlabeled, which I don't know is a cat's image or a dog's image. I just feed in those images to the computer, and the computer tells me if it is a cat's image or a dog's image. So this is supervised learning. Then supervised learning itself has got two types, regression and classification. Now regression is where the output variable that I was talking about, the label, the output variable is numeric values. Like for example, you want to predict the house prices of in an area. So the house prices here is the output variable, uh, which is a number. And a classification, now attrition prediction is an example of classification. So the output here is if a person, if my employee will attrite or not, if he leave the organization or not. So here my output is a yes no value. It's not a numeric value here, it's a yes no value. It's a categorical value, and that comes under classification. Now let's move on to the second type of machine learning. It's the unsupervised learning. So in unsupervised learning, what happens is you don't have the output label. You don't have the output label. So here, the kind of problems that you solve in unsupervised learning is very different from what we had just seen in the supervised learning. So here, for example, let's get back to our cat and dogs example. For example, you say you given images of cats and dogs to your computer. Now these are images are not labeled, so your computer cannot come up saying this image belongs to a cat or this image belongs to a dog, because we are not giving it that kind of information to learn from. But instead, the problem that you'll be solving here is you'll be creating two different groups. Cats, all the images of cats will come under separate group, all the images of dogs will be a separate group. So you're coming up with groups here, you're segmenting your data into groups. So this is an example of clustering. This is how clustering works. So yeah, so supervised and unsupervised learning, the main difference between them is that the labels, the output variable is present in supervised, and output variables are not present in unsupervised learning. So the computer does not have anything to go back to or check its answers against anything. Now, there's one more type called semi-supervised learning, which is an intermediate between your supervised learning and unsupervised learning. So how things work here is half of your labels, not even half, very few data will be labeled, and most of the other data will not be labeled. So the approach followed here is that you'll have two algorithms. In others, in the supervised and unsupervised learning that we just spoke about, there'll be only one algorithm, but here there will be two algorithms, and both the algorithms will start looking, they'll start with the labeled data first, and then from the labeled data they'll understand the pattern, and then these two algorithms will talk to each other about what they feel about the unlabeled data, and through this discussion uh, they learn. So that is how a supervised semi-supervised algorithm works. Now the third kind of algorithm is reinforcement learning. So reinforcement learning is a system learning by itself based on its past experience. Now let's take the example of a small kid, a baby. A baby does not know what a candle is, what a candle flame is, what happens if it touches the candle flame. So, and out of curiosity, the baby goes and touches the candle flame. So, and it ends up burning the finger. Now, next time when the baby sees the candle flame, it knows that no, if I go there, my finger will get burned. So I have to keep my distance from the candle. So this is an example of reinforcement learning. So a system learns by its experience. Now, this image will tell you more about reinforcement learning. It is like you're giving the image of an apple to your system and you're asking your system to identify it. And the system says it's a mango. You give a feedback, it's a mango. You give a feedback saying wrong, it is an apple. And the system notes the feedback, it saves the feedback for further for future. And then next time you give the image of an apple to your system, it gives you a reinforced response and says it is an apple. So this is how a reinforcement learning works. Now I'll take you through the basic workflow of a machine learning process. So the very first thing that you have to do when you are trying to solve a machine learning process is divide your data. Divide your data into testing, a training set and testing set. So normally the standards says that keep 70% of your data for training the model, and keep 30% for testing the model. Or it can be 80-20 as well, 80% for training and 20% for testing. So once you have your training and testing data separated, you you pick up your algorithm and you give this training data to the algorithm. You train the machine learning algorithm with your data. Now once the training is done, you get a model. You get a model out of the uh, algorithm using the data that you have passed to it. Now once you have that model, you give your test data as input to the model. So in test data, what happens is you know the output, but you're telling the output that no, I don't know the output. So you go ahead and predict for me. So what the model does is you are not giving the output to the model. You're just giving the input of the test data to the model. So what happens is the model goes ahead, predicts, and gives you an output. Now what you do is you evaluate this output against the actual output, and based on your evaluation, if the you decide if the model is actually doing good or not. If the model is actually doing good, then you go ahead and deploy it. If it is not doing a good job, then you go back and you train the model again. You change the algorithm altogether, or you do some tweakings in the parameters of the algorithm. You do something and you then come up with a new model. So this is a basic workflow of machine learning. Now a lot of companies in the industry uses machine learning, like Amazon uses machine learning for recommending products. Then so if you buy something on Amazon, you'll always see that if you have bought this, people who have bought this have also bought this. So these kind of recommendation engines use machine learning. And if you are a user of Pinterest, you'll know if you like some, based on your pins, Pinterest will suggest you what are the other kind of things that you're most likely to follow. Then Netflix also uses machine learning to predict, to recommend movies to you. And then you have Google uses machine learning in lot of ways. And now let's see an example of spam detection. So we all know what spam is, all the unwanted emails or the unwanted messages that we keep getting all the time. So here we'll make a model, a machine learning model, which will take as input all the emails or text messages. Now these messages are labeled. I'll show you. These messages are labeled. So the task of your machine learning model here is to identify which email is a spam and which is not a spam, a genuine email, which we are going to call as ham. So I have implemented this in R, and I'll take you through each of the code. So in the real class, we'll be writing the code. Since this is the demo class, I just have the code already written, but this is not how it is going to be in the class. We'll be developing each line of code in the class. So the very first step here is I'm trying to read in the data. It is a CSV data, so I'm reading the data. Read.csv is the function which helps me in reading CSV data, comma separated value file. So once I do this, you can see here a spam. So this is the variable that got created with this line of code. Spam is the name of the, so in R, I don't know how many of you are familiar with R, but in R, we have data frames. Data frames are like your tables. It will have rows and columns. So we call it data frame. Now with this line of code, read.csv function, a data frame gets created named spam. Now I have some information about this data frame given over here. It says the data frame has 5,572 observations and 5 variables. Now observations are the rows in your table and variables are the columns in your table. So this line of code gave me an output of, it gave me a data frame with 5,000 rows and 5 columns. So now we can have a look at this. So there are 5 columns in all, out of which I see only first two columns are populated for all the rows, and the x1, x.1 and x.2 columns have very few values. They have, yeah, so what I'm going to do is, I don't think these they have very little information to it. So what I'm going to do is I'm going to eliminate these 3 columns and I'm going to only use the first 2 columns. So this step over here, what it tells me is I'm going to update this data frame name, and I'm going to slice off the last 3 columns. So spam, this is the data frame name, and so before the comma you need to specify which all columns you want, and after, to the right of the comma over here, sorry, so this is the comma, to the left of comma you need to specify which all columns from the database, from the data frame you want, sorry, which all rows you want and which all columns you want. Now in my case, I don't have anything to the left of the comma, which means that I want all the rows, and to the right of the comma I have something saying 1:2, which means I want columns from 1 to 2, means I want the first 2 columns. So if I do this, if I run this, my data frame got updated. Now it has 5,572 observations or rows and just 2 columns. So I have gotten rid of the unnecessary columns here. Now the names of the columns don't make sense. So it's V1 and V2. Since it is very few variables, very few columns here, it's okay if we work with this column name also. But when we are dealing with large number of columns, it is always better to have the names which make some sense. So I'm going to change the names to class and text. Let's see. So now the names have been changed to class and text. So the class here means, so the text is messages. You have these many messages, and each message is labeled, like our cat and dog example, each message is labeled over here. Each message is either labeled as ham or it is labeled as spam. Okay, now let's plot a graph, a very basic graph, to understand how the data is distributed, to understand how many spams we have and how many hams we have. So for that, I'm going to need this library called ggplot2. I'll run this. Okay, now the library is loaded. Now I can use this ggplot function to plot the graph. Yeah, so here is my output. So so you can see the plot in pink and blue over here. So the data tells me, the graph tells me that most of my data is ham and very few data are, so yeah, close to more than, it's almost more than 4,500 of the data of the text messages that we have are genuine, are hams, and very few of them, less than 1,000, are spams. Now Now the next thing that we do is we just shuffle the data. So whenever we work with data, whenever we try to create some models, we should make sure that the data comes from the data is randomly arranged. There should not be any sequence to it. It should be all random. So this step here, if you see the numbers over here, 1, 2, 3, 4, 5, 6. It is serially organized now. And if you see the first line over here is go until Jurong point. So this is the first text message. Now we want to shuffle this data just to make sure that there's no bias. There's no bias in the model that we create later on. So we are just shuffling the data. So here what happens is we use this function called sample. So what it does is it creates a random, for example, sample. So if you look at the bottom of your console, this is the console, and if you look at the bottom of the screen, I'm typing something. Suppose I want to generate. So if I give this sample of 5, it means that I want to arrange the numbers from 1 to the first 5 numbers 1 to 5 in a random or sequence. So this is how it gives me. So here what I am doing is to this sample function I'm giving as input the number of rows of span. That means our data frame. So n row of spam, number of rows of spam is 5572. Now we are giving this number as input to the sample function, and we are to the left of the comma, you see this sample. So you're changing the order of the rows. When we run this, if you see, all your data is randomly organized, and now it is no more first, second. The sequence is no more there. The first message has changed to something else now. So now you're sure that your data is shuffled. There's no sequence to it. Once that is done, we need we load this library called Quantida. It's quantitative analysis of for textual data. So we load this library. Now this library will help us in mining text, in processing your text data. So once this package is loaded, once this package is loaded, now the next thing that you do is you create a corpus. You create a corpus out of your text. So for that, you need your text column. You need this column to be in the to have the correct data type. Now let's check the data type first. So this will give, sorry. So this will give you the class of each of the variables of this data frame. Now it says the text column. The text column's data type is factor, but you don't want it to be factor. You want it to be a character. So what you do is you write a function. There's a function called as.character which will convert anything into a character. Now in our case, our text column is a factor. Now you need to convert this factor into a character. So you use this as.character function. To this function, you're passing spam text. Now to address any column, this is the syntax that you use. Spam is your data frame name, followed by a $sign and followed by your column that you want to access. So as.character and specify the column name that will convert the factor into a character, and it will put it back into the same column text. You're not creating any additional text. You're not creating any additional column over here. You're just changing the type of your column from factor to character. So you have done, as you see, there's no extra variable added. There are still just 2 variables, 2 columns. Now if you run this again and see the type, it says now the data type of your text is character. It is no longer a factor. So once that is done, you create a corpus out of corpus is basically like a summary. Okay, so if you want to see how this works is, Now message corpus is the corpus that you have created out of your text variable. Let me see the summary of this. So if you see here, it says corpus consists of 5572 documents. Now each of your text, each of your text row, but it is called a document. And so there are since there were 5572 rows, there are 5572 documents in your corpus. And so this is like your data has got summarized in your, say in your text one, you have 7. Okay, now you have types, tokens, and sentences in your corpus. Now sentences means obviously there are 2 sentences in one text in one document. Now tokens means how many words are there in your document. It does not take into account if a word is unique or not. It will just count. For example, hello, this is Veena. Hello. So Veena. So there are five tokens, but when you look at types, it will not consider the repetitions. As in, hello, this is Veena. Hello. I'll just type it over here for better understanding. Okay, so this is my sentence, and say when I'm talking about tokens, there are 1, 2, 3, 4, 5 tokens, but types will be only 1, 2, 3, and 4. Hello, this is Veena. Since this hello over here is coming for the second time, it is not unique, so it has already been counted, so it is not going to be counted again. So that is the difference between types and tokens over here. Now, once you have the corpus in place, now the next thing is you want to give your class labels to this corpus. So you have this um, attribute called doc wheres in your corpus. So you update that attribute to spam class. Spam is your data frame followed by a dollar. Class is your column. Once you run this, let's do the summary again. Now you see that there's an extra column added over here, extra column added in your corpus. Earlier it was just text type, tokens, and sentences. If you see up, there's no class variable here, but here you have class also. So you have this summary like text one. What are the types? I mean, how many unique words are there in that text, in that document? Then how many words in total are there in the document? And then the document contains how many sentences? And what is the category of that? What is the class of that document? Is it a ham or is it a spam? Ham. So this third one is a spam, like that. Now, once we have this, what we are going to do is we are going to split the data into testing and training sets. So here I'll keep 80% of the data for testing. So 5572 into 0.8 is 4457. So 4457 rows of data will go into training set. Now our data is randomly arranged, so we don't have to worry anything. We just have to take the first 4457 rows and give it to the training set, and then the remaining rows will go into the test set. So I'm creating a new data frame here called spam train, and so this follows the same syntax, the data frame name, square brackets, followed by a comma first. Then to the left of the comma, I'll mention the rows that I need. So I want the first 4457 rows. So 1 means to 4457 means all the rows starting from 1 and ending at 4457th position. And I'm keeping this part blank because towards the right of my comma, everything is blank because I want all the columns. I'm not eliminating any of the column. I want all the columns, but I want only these many rows. So I'm chopping my data set now. Once I do this, a new data frame gets created. It is called spam train, and it has got 4457 observations, meaning rows, and 2 variables, meaning columns. The columns remain unchanged, just that the number of rows have reduced here. Now, similarly, I'll keep the remaining 20% in the test set. So I'll create a new data set containing the test data. I'll run this code. So sample spam test is the new data frame that should get created after running this code. So spam is the data frame name. To the left of the comma, I mentioned 4458 as the starting location and ending at number of rows of spam. Number of rows of spam will give me the row number of the last row, right? And to the right of the comma, I don't have any values entered again, which means that I want all the columns. So if I run this, one more data frame got created, which is called as spam test. It has got 1,115 rows and 2 columns. Now, okay, now now the next step is to create a DFM. Now, it is a DFM is a document feature matrix. Documents are nothing but your rows, and features are your so think of it as a table. So yeah, so in the rows you have your documents, and in the columns you have each of these words. Suppose so just imagine that you just have two documents. A first document has 5 words and the second document has 8 words. So in all you have among these two documents, in all you have 8 words in total. So your DFM, your document frequency matrix, will have 2 rows and 8 columns. Okay, 2 rows and 8 columns. So you need to create a document, you need to create a matrix like this out of your corpus. That is what you're doing in this. So this function called DFM in your Contata package, for which the inputs will be message corpus, the corpus that you had created. You're giving the corpus as input, and 2 lower is equal to 2. That means all the characters will be converted into lowercase. So once you have this, yeah, now that document frequency matrix has got created. We are doing this because for our algorithm that we will be using, we need to give input in the form of this matrix. So that's why creating this matrix is important. Now, once the matrix has been created, you see here it has got these many elements, 51412844 elements. Now we will trim the DFMs. We'll get in. These things might sound a little difficult now. We'll get into the details when we reach the top, when we reach the text, when we are at the text analytics topic. So for now, this DFM, this function called DFM trim, what it does is you need to give it limitations. You need to tell that minimum term frequency is so much, minimum document frequency, meaning minimum document frequency means this word should have at least appeared in 3 documents to be seen in the DFM, meaning if it has to come in this frequency document frequency matrix, it has to appear in at least 3 documents. Similarly, term frequency is like if this word has to appear in this DFM, then in each document it should have in each document it should have at least appeared 5 times, like that. So once we have this DFMs, your matrix in place, now the next step is you have to divide this matrix into training set and testing set. So again, you do the same thing. Just run these two. Yeah. So I'll create a training DFM, document frequency matrix, which is the same what we had discussed here. 1:4457. So this gives me message DFM train, okay, and testing DFM, just like how we had done it here. So I'm not explaining it in detail here. Now, once we have the message DFM, the training and the testing DFM, training and the testing matrices, we move ahead with the model creation. So here the model that I have chosen is knife-based model. So generally for text mining, this is one of the models that is used. And we'll get into the details of this model later in the class. So this function over here, text model NB, knife base. So this is the model, this is the function used for creating a knife base classifier object. So and the inputs to this function are the training DFM. So the input to this function has to be a DFM. It has to be a document feature matrix. You can't give a plain data frame to it. It won't throw you an error. So that is why you bothered about creating all this DFMs. So you give the training DFM as input, and then you give the class label. So you give the class, so spam train, uh, here spam train, again the same thing, you're chopping your data, creating a subset of your data set. So here you want all the rows of your spam train data set, but you don't want, I'm sorry, yeah, you don't want all the columns. So you just want the first column, which is the class column. So once you run this, your model comes, the knife base algorithm comes out with a model. Now what we are going to do is, we are going to use this model on the testing data. As I had mentioned in the workflow of machine learning, we have come up with a model now. Now we will use this model on the testing data. Okay. So we have this predict function. Predict function takes the model object as as a parameter along with the test data. So here, this is the model that this is the knife base is the algorithm we have used, and this will create a knife base object model of knife base model object. NB classifier is your model object. Now this model object you're passing as a parameter to the predict function, and along with that you're also passing the test the test DFM. Okay, the test DFM you're passing along with it, and you're asking your system to predict. So your system comes up with a prediction. Now it has come out with some prediction. Now we will see how well the system has predicted. We'll create a confusion matrix. I don't know if you all are aware of what a confusion matrix is, but we'll see it later in details. So you create a table like this, which will give you what the values of the predicted values against the actual values. So here what it means is that the diagonals over here, the diagonals is the error. Sorry, the diagonals over here, this 939 and 141 is the correct predictions, and this off diagonal 27 and 28 is the error. What it means is that 27 were actually hams. 27 of my predictions were actually hams, but it were predicted as spams. Similarly, 8 of my predictions were actually spam, but they were predicted as hams. So these are the this 27 and 8 is the wrongly predicted values, and 939 and 141 are the correctly predicted values. Now to see the accuracy of the model, what we do is very simple measure to see the accuracy is this 939 plus 141. These are my correctly predicted values. This divided by the total. Now our total is 939 plus 141 plus 8 plus 27, which is 0.96, which is 96%. That means 96% of the times my model has correctly predicted the test data set. Now, in simple, this is the simple way of doing of getting this value. If you run this, so it means that the values are predicted equal to this the places where both the predict function and the predict object and the spam test class were equal. You take a mean of that and you get this value, which is 96%. So this way we have seen a model which has an accuracy of 96%. So what we are trying to do here is we have a data set of around 5,000 rows, and then we divide it into two, training and the testing set, and the training set is being used to create a model. Then we use this model to predict the output of test set. Now you actually know the output of test set, but you're telling your system that no, I don't know the output of test set. You just go ahead and predict for me. So your system predicts, and then you compare this actual values against the predicted values, and you saw that my system was accurate 96%. The accuracy of my model was 96%. That means my system has incorrectly predicted, my model has incorrectly predicted 4% of the data, which is a good model. So this is about today's demo session. I would also like to brief you about the course contents. So if you've gone through the course on our website, you might have seen. So in the course, we'll be talking about what data science is and how is it different from machine learning, and basically the introduction of data science along with some use cases. Then next is statistics. Now, although you don't have to be an expert in statistics, you don't have to know everything in greater details, but there are a few things which you must know before you go ahead with machine learning. Like probability is one thing which you have to know before you try to understand any machine learning, because what I told you now is just it looks very easy, but behind that, if you see, there are a lot of complex mathematics going on. You don't have to I mean, we are not expected to know all the mathematics that goes behind it, but then there are a few basic things that we must know. So to understand that, we have this statistical topics covered in the syllabus, like probability, then probability distributions, your normal distribution, Poisson distribution, etc. And then you have your central tendencies, like your mean, median, and mode. And then hypothesis testing, which is very important concept again. Then the types of errors and statistical methods like z-test, t-test. All this will be covered under this topic. Then data science tools. So today I have used R, but R is not going to be the only tool that we are going to use, because the aim of this course is so that you should be able to program in both R as well as Python. We are not limiting it to only one, to any particular language, but you'll be after the completion of this course, you'll have a good understanding of how to program in both R as well as Python. So I'll be telling you how to install R and Python on your systems, and then we'll cover this NumPy is a library in Python which helps you do all this mathematical numerical basically arithmetics on your data. And pandas, so in R we saw that the data is by default arranged in a tabular format, but that is not how it is in Python. In Python you need to use this pandas library to get your data into that format. So all this will be covered in this topic. Then you have data processing. Now, so since most of you have already worked with data, have a good understanding about data, we know that data never comes in a very perfect format. We have to bring it into the right format. Many a times your data will be scattered among different tables. You'll have to pick up the important variables from each of the table, and you'll have to merge it into one, and that's how you get the table that you actually want. And then similarly, aggregation of data. Suppose you have your daily sales data, but you're trying to solve a problem where you want to look at your data in a monthly format. So you have to convert this daily data into monthly data. These kind of this is where aggregation comes into picture. So these kind of wrangling you have to do with data, that comes under data pre-processing. We'll be covering all those topics under this topic heading. Next is data visualization. You have various visualization libraries like your matplotlib, like what we saw in R just now, ggplot. So using all these libraries, how you can come up with beautiful graphs, how you can add details to the graphs, are what we are going to see in this module. Then comes exploratory data analysis. This is exploratory data analysis is also should also be a part of your pre-processing module. there isn't much difference between, because it all comes under one single umbrella. So here what we do is, once you have your data, once you get all the columns that you want, you have converted it from daily format to monthly format. Now you have your data in the perfect table that you are looking for. Now the next step comes, that you need to identify, you need to find out how many values are missing in your data, or if there are any outliers. Outliers means, for example, you have a variable called age, and there are two or three variables where age is mentioned as 500 and 600, which is not possible. So these values are outliers. So in this module, you will see how to handle these kind of outliers. Should you just delete these values, or should you use some method to impute those values? So that we are going to see in this module. Then comes introduction to machine learning. So here, just like I spoke in today's demo session, we'll be covering all the basics, like what machine learning is, what are its types, and the workflow. And then we'll look at regression classification and clustering in greater details. Then we'll be talking about regression in this module, only about regression. What are the types of regression? We'll be solving some interesting problems here, like you will have to predict the sales of some retail chain, and or you'll have to predict the price of a car. Problems like this will be solved under this regression. Similarly, you have classifications. In classification, okay, one more thing. In regression, the algorithms we'll be learning is simple linear regression, multiple linear regressions, then support vector regressions, support vector machines basically, then decision trees, random forest, etc. And then we'll go to classification techniques, classification methods. So here the algorithms that we'll be covering is KNN, which is your K nearest neighbors, then support vector machines, naive Bayes, which we just saw, but we'll be seeing it in details how it actually works. Then your decision trees, random forests, and we'll be solving problems like churn prediction and problem, yeah, etc. Then we have clustering. So we have two modules for clustering. Now there are two types of clustering actually. One is k-means clustering and one is hierarchical clustering. So the difference between the two is that in k-means clustering, you begin with one single partition, you begin with one single group, a cluster, and then you go ahead dividing it into smaller clusters based on the similarity. And in hierarchical clustering, what happens is each individual data points is divided into, suppose you have 50 data points, you will start with 50 different clusters, and then based on similarity you keep on grouping them into clusters, where each cluster will have data points that are similar to each other. So in k-means also, we'll be teaching you how to implement it in Python as well as in R, and we'll be solving problems like customer segmentation over here. Then in hierarchical clustering also, we'll be solving many problems using both R and Python. Few of the problems that we'll be solving is, say, social network analysis. We'll solve an interesting problem in social network analysis. We'll also look at sentiment analysis in these topics. I'm sorry, not sentiment analysis. Sentiment analysis comes here. So next topic is natural language processing. So today what we did was a bit of natural language processing as well. That's why I told you don't get into the details now. We will look at it when we cover these topics. So tokenizers, stop word removal, TF-IDF. So if you want to do this using R, you use a quanteda package, and if you are doing it with Python, you use the NLTK package. And this tokenization, TF-IDF, are something which was already taken care by this quanteda package in our program today, but just that I didn't get into the details at that level. Then here we'll solve a sentiment analysis example. Then we have artificial neural networks. We'll be talking about what basic neurons are, and then we will tell you about what activation function is, then how these neural networks work. and we'll be talking about backpropagation neural network, and we'll solve a problem of solve a problem wherein we are given a lot of face images, and we'll try to identify what emotion this face shows using this backpropagation algorithm neural network. Then we have TensorFlow basics. We'll be talking about what TensorFlow is, how you can use it to solve these machine learning problems. We'll solve some problem using TensorFlow as well. And that's it. Then you'll be put on some live projects, as Saurav had just mentioned in the beginning of this session. So that's it from my side. Thank you.
Thanks a lot, ma'am. Thank you. It's really nice. So, guys, just want to add a couple of things from my end. As you could see in this demo session, there are many points, or there are many activities which Veena ma'am covered, which may be at a higher level side, but that is what is all about, in terms of the practical trainings. When the actual training gets started, obviously, we are going to start from the scratch. There are a lot of keywords or terminologies within the session, Veena ma'am, which use. So first of all, she'll make you familiar with all those terminologies, data types, and the keywords, and what is the purpose of that. But ultimately, at one point of time, we have to start doing it practicals, more and more practical learning. So there is nothing in a PowerPoint presentation. In most of our sessions, we are not running 50 or 100 slides PowerPoint presentations, and we are just discussing without actually implementing and all. So that is how we are actually conducting. So now I just want to make it as an open forum. Will be open for take questions. So one by one, maybe I'll ask you if you have any question for me or Veena ma'am. Please feel free to do that. So let's start with Jay Prakash. Jay Prakash, can you unmute yourself?
Yeah,
Yeah.
I'm here.
Hi, Jay Prakash. I think you joined late.